Okay, so hi guys. So I was doing a video. The thing is that, yes, it's a little bit, I would say, because the number that I had chosen for this problem, um, was a little too big. um, because I had chosen 50 instead of this one. I chose 17 because I believe that's a little bit less, it's because with 50 it's a really long number. But yes, basically with this, we have this problem here. It says, find the 17th term of the geometric sequence. Okay, now, this is a sequence, right? We have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Now, what do you notice about this sequence, though? What do we notice? Every time that we go from, when we go from 3 to 9, we multiply 3, and then we go to from 9 to 27 times 3, from 27 to 81 times 3, from 81 to 243 times 3, and then we keep going, right? And we want to know what the 17th term of the geometric sequence is. And rather than actually actually multiplying it out all the way to 17, in reality, it would be a lot better to just do, so there's a specific formula for this. And I know this chapter has a lot of formulas, so that's why we have to be very careful, and that's kind of why I'm going over all of these formulas in a couple of videos, because if I go over this chapter in one sitting, it's going to be extremely difficult, and it's going to be way too much. So that's why I'm going over it per video. Okay. Now, this is the definition of a geometric sequence. This is from the textbook. That is this one here. It is called Precalculus Mathematics, so it's with it's from Stewart. So and like I said, this is actually the book that I had when I was in Precalculus in college. So it's Precalculus Mathematics for Calculus 7th edition, and I will put a link in the description down below for the book in case you want to look at it. But yes, this is where I got this from. So so basically, so what this is saying is, this is the definition of a geometric sequence, okay? It says that a geometric sequence is a sequence of the form, or actually, let's read this top part first, okay? It says, recall that an arithmetic sequence is generated when we repeatedly add a number d to the initial term a, right? That's when we did a sub 1 plus d times n minus 1 is equal to a sub n. That's what we know, right? And yes, and the initial term in reality, they call it a. That's because they said that a sub n is equal to a plus d times n minus 1. But I always like to say a sub 1 because that's literally the first term in your sequence, okay? So this is, in my own opinion, you can write it however you want, but if you don't want to get confused with what a is, I recommend that you write it this way. So because that just makes it so much easier when it comes to it makes it so much easier when it comes to actually doing it, right? So that way you don't have to know what a is if you're confused about what a is. But anyways, it says, so it says when we repeatedly add a number d to the initial term a, or a sub 1, right? That's why we have a sub 1 here. A geometric sequence is generated when we start with a number a sub 1, or a term a sub 1, the first term, and we repeatedly multiply by a fixed non-zero constant r, okay? What that means is that the constant r, it just means any number r such that r does not equal 0, okay? So it says a geometric sequence is a sequence of the form A, so basically, or we can say rather, we can say AR squared, AR cubed, AR to the fourth, etc. And in reality, this is going to be equal to, so it says the number A is the first term, so basically it's a sub 1, and then, you know, etc., right? And then it says r is the common ratio of the sequence, and then the nth term of a geometric sequence is given by a sub n equals a r to the n minus 1. Now I wanted to rewrite this, and I wanted to say that this is really just a sub 1 r to the n minus 1. Okay, let me actually, hold on, give me 1 second, guys. So yes, this is what it is. It's a sub 1 r to the n minus 1, right? So, in this problem, we want to know, so basically, we keep multiplying by 3, so obviously, anytime you keep multiplying by a specific number, that's your ratio, your common ratio, okay? And we want to find the 17th term of this geometric sequence. Now, obviously, we're not going to keep going in terms of like saying 243 times 3. We're not going to keep doing that over and over until we get to the 17th term, because of course it gets a lot harder, right? Basically with this, how we do this problem is we're going to, so obviously we already know the common ratio. It's 3, 9, 27, 81, 243, so we keep multiplying by 3. So that means that r equals 3 here, okay? We know that r equals 3. Now, let me actually, yeah, I'll just do it this way. So that's what that is. R equals 3. So that's what that part is. That's what that part is, basically. Now, if we want to find the 17th term, we're going to say that n equals 17, because that is the nth term that we're looking for, right? And then, so we're going to say a sub 17 is equal to, and it's going to be whatever a sub 1 is. So a sub 1 is 3. We know that a sub 1 is 3 because it's right here. A sub 1 is 3. So 3, and then the common ratio we know is going to be 3, right? It's going to be 3. And then, so it's really going to be to the 17 minus 1 power. Now, you can use a calculator to know exactly what this is. So basically, you're going to do, so it's going to be 3 times 3 to the 17 minus 1 power, right? And that's just going to be, so in reality, the 17th term is going to equal, and if you want to do this in an algebraic way, like if you remember from algebra that this is really just, basically it's really just 3 to the first times 3 to the 16th, and you want to do like laws of exponents, you can do that. It's okay to do that. So in reality, this is just 3 to the 17th. But yes, it would just be 3 to the 17th, and that is just equal to 129,140,163. So that is the 17th term of this geometric sequence. Is 129,140,163, okay? And that's how you do this problem. So that's kind of why anytime you run into a problem like this, you have to kind of know. That's why I'm doing it like in terms of problems, because in case anybody finds a problem that, you know, because sometimes we look for specific problems that we want to know how to solve, and sequences and series, and every other chapter has a number of different kind of problems. So that's why I guess nowadays I'm doing my videos in terms of problems instead of just a whole chapter, if that makes sense. So with that being said, guys, I really hope this helps. So the answer to this one is 129,140,163. And if anybody has any questions, please let me know. Please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.